Most developers think volatile make thing thread safe. It doesn't. It solves the problem of visibility, not atomicity. And confusing these two can cause real bugs. Let's look at a problem. We have a flag whose value is false and there are two threads. Thread 1 update the value of flag to true. Thread 2 is waiting for the value to be updated. Now do you think as soon as the thread 1 updated the value of flag, will thread 2 be able to see the updated value? Not without volatile keyword. So volatile keyword ensure three important things. First is visibility. Let's say we have thread 1 and thread 2. They are reading the value from memory. Let's say the value of flag is false initially. Okay. When thread 1 and thread 2 will read the value from memory, usually they cache this in CPU memory or CPU cache or registers. And whenever they are performing operation, they refer this value from the CPU cache. Now in this case, let's say thread 1 updated the value of flag to true. So this will eventually be synced to the memory. While parallelly thread 2 is working on the same flag, it may not see the value update because it is reading the value from CPU cache. What volatile does is it introduces memory barrier. With memory barriers, threads are forced to read the value from main memory instead of CPU cache. So if thread 1 update the value of flag to true, it will be synced as directly to the main memory, and thread 2 will directly read from the main memory. So they both will be referring to the updated copy of the flag. Secondly, volatile keyword prevent reordering. So usually when we talk about object creation, let's say, it consists of three steps. First step is allocating memory, second is initializing object, and third is reference assignment. Sometimes JVM reorder the instruction for optimization. In that case, the flow can be allocate memory, then assign the reference, and then initialize the object. Now in this case, partially assigned object is assigned to a variable. Any other thread executing at the same time can use this uninitialized object, and which can cause further issues. So volatile keyword prevent reordering of instruction in JVM. Real-time scenario where this is helpful is when creating singleton object. Now we'll discuss about this in some separate video. The third thing that volatile ensure is happens before. If both the thread are running in parallel, any operation can be executed first. Right? So it can happen that thread 1 writes the instruction to the memory and then thread 2 reads. But it can also happen that thread 2 it read the value first and then thread 1 write the value. For these scenarios, volatile also ensure happens before. It ensure that if there are two operation write and read simultaneously trying to execute, write operation will happen before read operation. That is the happens before rule. Now if we compare volatile with synchronized, volatile ensure visibility but it does not ensure atomicity or it does not provide locking. Performance wise, it is faster than synchronization. Now, to give you a mental model, volatile keyword ensures visibility and reordering, not atomicity.